Okay, so again, we are still on lesson 3, but this is the last lesson for rotation as agreed, no, in during our previous um, meeting, wherein di na ta mag-proceed for non-centroidal. Let's stick to centroidal rotation na lang. So this is kinetics of centroidal rotation. Let's have some additional problems. I hope inyo to i-recall ang ato ang previous nga discussions, even if nag-agi mo sa quiz number 1 for dynamics. Let's focus here, no? Focus on the combination of those concepts from rectilinear translation and also rotation. So for problem number 1, this is the problem statement. The compound pulley in the figure below, this is the figure, is made of cast iron with density of 490 pounds per cubic feet. Find the tension in the cord supporting the 161-pound weight and the bearing reaction. Neglect the weight of the cord. In our illustration, we have two weights, 161 pounds and 322 pounds. The one is heavier than the other, and then this is our compound pulley, no? It comprises of two pulleys with different diameters. This is the cross-sectional area, or this is the side view of our compound pulley. So ang thickness sa kaning 1 inch radius nga pulley is 0.5 feet, and then for the 3 inch radius nga pulley is 0.5 feet. Okay. Now, ato i-determine ang mga objects nga na-involved. We have the first one. Let's consider the 322 pounds as our first object. Our second object is the compound pulley, and then the third object is our 161 pounds nga block. And then let's write the requirements for this problem. We are to solve for the tension in the cord supporting the 161-pound weight. So this one right here, ato siya i-let as T2. Okay, the tension. And what else? Ato sad pangitaon ang bearing reaction, or that is the reaction at the compound pulley O, kaning center at O. Okay. So first step ni ani is that we are going to generate or to create an FBD for the entire system. So this is our system. Now we have two blocks with weights. So therefore, ang obvious nga itong ma-definean sa ilang external forces are the weights. And then considering the first object, no, object number 1, this one right here, since kay nakasuspend man siya by this rope, therefore the rope exerts tensile force. So T1, T1. And then after that, for the for the left rope pod, it supports the 161-pound weight, and then that rope exerts a tensile force. We label that one as T2. And then of course our compound pulley has a weight, and then the force that supports our uh, compound pulley, the weight of the compound pulley and the other external forces that affects our compound pulley is the bearing reaction labeled as RO, which acts at the center of our pulley. Now, for our 322-pound block, our first object, we consider this one, or we treat this one as a particle because its dimension is neglected during our analysis, and then its size is smaller compared to its path of travel. And then for object number 2, our compound pulley, we consider this one as a rigid body rather than a particle because its dimensions, the radii, no, are very important in performing motion analysis. Okay, and then the path of rotation is smaller compared to its size. So therefore, this is a rigid body. The last object, okay, object number 3 is our 161 pounds block. So the dimension here is not so important in motion analysis, and then its dimension also is very small compared to its path of travel, which is vertical. Therefore, we consider this as a particle. The same with the 322 pounds nga block. Now, by comparing the weights, we can say that the 322 pounds block will fall downward, and then the 161 pound block will be carried, no, along the way. Kay mas lighter man siya, so mutaas gid ni siya. So the direction of acceleration for our heavier weight is downward, labeled as acceleration 1 or A1. So if ang 322 pa downward, therefore the smaller radius nga pulley mo rotate siya pa clockwise, and then its angular acceleration is alpha. Now if this compound pulley rotates clockwise, so it is obvious that the 161 pounds block will be pulled upward. Therefore, its acceleration is upward, labeled as A2. So these are the external forces as well as the direction of our acceleration. Okay, so ato ni siya tagsa-tagsaon ang mga objects na involved. We have 1, 2, 3. Okay, ato is sum up ilang mga forces so that we can get the tension at the 161 pound blocks as well as the bearing reaction at the compound pulley. Okay, but before that, since this problem, the centroidal moment of inertia of our compound pulley is not given, so we need to solve it first. Okay, now our compound pulley, the side view, looks like this one. So kaning gray color. Now, if you're going to solve for its total centroidal moment of inertia, let's dissect this one. No? So this compound pulley, we can redraw this one into this. So we have a solid cylinder wherein gikan ni siya sa inner radius. So our inner radius is 1 foot. Therefore, its diameter is 2 foot. 2 feet. And then its length is the combination of the lengths of the smaller pulley and the larger pulley. So that is 1 foot. Okay. So we have a solid pulley plus the moment of inertia of this hollow nga pulley. Okay. So ato siya ko nag cross sectional area ato butag hatch, and also this one meaning gikat ni siya. So therefore we have a hollow cylinder. Its inside diameter is equal to the diameter of this solid cylinder. So this is 2 feet, and then the outside diameter is 3 times 2, so this is 6 feet. Okay, this one is equal to the entire compound pulley kung ato siya i-combine. Okay, so therefore we need to find the moment of inertia of this solid cylinder. Then the moment of inertia of this hollow cylinder is equal to the total centroidal moment of inertia of this compound pulley. So that is I of the solid cylinder plus the mass moment of inertia of the hollow cylinder is equal to the centroidal moment of inertia of this compound pulley. Ato lang bar. Bar means centroidal mass moment of inertia. Now, for a solid cylinder, wherein its axis is at its geometric center, no, don't forget, ang axis of rotation niya is at the centroid, no, kani, naman siya at point O. Therefore, remember, ato ang formula for mass moment of inertia for solid cylinder, that is equal to 1/2 the mass of this solid cylinder times the radius, no, that is ato na ibutang r square plus this one 1/2 mass of this hollow cylinder times the larger radius square plus the smaller radius square, that is equal to the centroidal mass moment of inertia. Now for the mass, don't forget that the mass is defined as density times the volume. Okay, so we're going to use this one. Since given the density, then we can calculate this. So applying that one, we have 1/2 density of this compound pulley, and the volume of this solid is, we have 2 pi, I mean not 2 pi, that is pi r squared, sorry. Ang 2 pi is for the circumference. So this one is pi, the radius of this cylinder, so pi r squared, and then its height, actually labeled as the height of the solid cylinder, and then another r squared, plus 1/2 this one density, and then how about for its cross-sectional area? Okay, so that is pi times the difference of the square of the radius, that is r square minus r square, and then the height of this hollow cylinder, so actually labeled as height of the hollow cylinder, then r squared plus r squared, and that is equal to I bar. Now if ato i-plug in ang mga values, so just follow this formula, no? Let's follow this formula. Let's start with the leftmost part of the formula. So kani siya. So we have 1/2 0.5 times, okay, sorry, naka-stat mode siya, to ato ibalik ang compute mode. So 0.5 times the density, given ang density, that is 490 pound per cubic foot. So 490 times shift pi, tapos r squared and r squared, we can combine this, and this will become r to the fourth. So the radius of this solid cylinder is 1 foot. So raised to the power of 4 is still 1, times the height of the solid cylinder is 1 foot. So 1 lang. The result is 245 pi. So we have here 245 pi plus, let's simplify, or let's evaluate the second term, this one, medyo taas ni. So 1/2 times the density is 490 times the volume is shift pi, and then the difference of the two radii. So ang larger radius is 3 square minus smaller is 1 square. Tapos ang height aning hollow cylinder, I forgot to put it here. So this is 0.5 feet. Okay, so put here 0.5, and then r squared plus r squared. So we have 3 square, sorry, I forgot the parenthesis. So 3 square plus 1 square. So we have 9,800 pi. So we have 9,800 pi, which is equal to I bar, or simply I bar is equal to, let's add this one. So 9,800 pi plus 245 shift pi. The result is 10,045 pi. So we have 10,045 pi. The unit is foot-pound second square. Okay, we now have the value of our centroidal mass moment of inertia for our compound pulley. The next step is to evaluate the forces for each object. So let's start with object number 1, that 322 pounds block. So ato sa ipang define fully ang mga forces na involved. So we have the weight, we have the tension sa rope, and what else? So this one is in dynamic state. So therefore, let's make this into a dynamic equilibrium condition. So in order for this to have a dynamic equilibrium state, so ato i-determine ang iyahang reverse effective force. So the REF again is opposite to the direction of the acceleration or the direction of motion. And REF is the weight over G times the acceleration. So we take summation forces along the vertical, that is equal to 0. So by defining the REF, we can use now the equilibrium equations. So we take positive if pa-downward ang mga forces. So why positive and downward? Because this is the direction of motion. So what are the downward forces? We have the weight, 322 pounds, minus na sa tension 1, and then minus sa REF. Okay? Minus REF. Okay? So minus na siya sa REF. Then that is equal to 0. So tama ba? Okay, tama. So next ni ani, REF is weight over G. So 322 minus tension 1 minus 322 all over 32.2 times A1 is equal to 0. Now let's rearrange this one. Mag-una ang acceleration 1, tapos ang iyahang kuan, ang iyahang tensions. However, no, we can still modify our acceleration 1 in terms of the angular acceleration alpha, no? Because the acceleration of this block and the acceleration at this particular point, which is tangent to this smaller circle sa ato ang compound pulley, they have the same linear acceleration. So the relationship for linear acceleration and the angular acceleration is given by A1 equals the smaller radius times alpha. And the smaller radius is given by 1 foot. So that is 1 times alpha, or just simply alpha. Therefore, the first acceleration is alpha. So rearranging this first equation, we have negative 322 all over 32.2. So alpha 1 is, A1 is equal to alpha. Then minus T1, then equals, ingat to ang constant. So negative 322. All are negative, multiplied by negative 1. So therefore, final equation for our equation 1 is 32.2 over 2 alpha minus T1. This is T. And then, plus na di kaya na multiply ng negative is equal to 3 to 2. This is our first equation. So, kindly take note this. Let's proceed to the second figure. Our second figure is our compound pulley. Our pulley rotates counterclockwise based on this direction of our angular acceleration. Now, our compound pulley, unlike the blocks, no, the blocks sa previous is it moves on a straight path. Therefore, our tool in analyzing its motion is by using the rectilinear translation. But for the compound pulley, since the compound pulley rotates at a particular axis of rotation, which is at its center of gravity, therefore we use rotational motion analysis for this. So naamantay kon ato, since ni coincide man ang iyahang centroidal rotation, ni coincide ang iyang center of gravity, which is located here, as well as its axis of rotation. So therefore, ma-equal to 0 tong summation of forces along the normal and along the tangential. Ang importante ra nga magamit riya is the summation of moments at the center. So here, we take summation of moment at the center is equal to its centroidal moment of inertia times the alpha, or the centroidal mass moment of inertia. Now, we take positive if all those external forces, no, tends to rotate our compound pulley pa-clockwise. So, paana siya. Or this is CC. So, what are the clockwise forces? We only have T1, no? Si T1 pa-clockwise siya. However, for T2 pa-counter. Now, how about the weights and the bearing reaction? So these two don't have a moment arm because they are directed towards the axis of moment. Therefore, ma-zero sila. So wala sila ilabot kay ni-act man sila, no, towards the axis of moment or the axis of rotation. So therefore, ang naara dire is T1. So we have T1 times its moment arm, which is the R1, minus T2, and then the moment arm is the larger radius R, no? Or pwede lang dili R1, no, kay na-distinguish naman so just simply R lang, no? It's already okay. Then that is equal to I bar alpha. Now let's rearrange this one, no? So mahimo na siya og I bar alpha minus the smaller r daw at the transpose nga to, as well as this one transpose nga to. So we have alpha, I mean I bar alpha minus our r here, no? R is equal to 1 foot, and then the bigger radius is equal to 3 feet. So that is minus T1 plus 3T2. Okay? That is equal to 0. Now, nakakuha na taog I bar, which is the centroidal mass moment of inertia, 10,045 pi. So 10,045 pi. This is 10,045 pi alpha minus T1 plus 3T2 equal to 0. So this is our second equation. Ato na siya tigaman. Now, proceed ta sa third nga object, kaning 161 pound nga block. So, ang behavior ani niya is rectilinear, no? Pa straight line lang iya hapat, wala siya nag-rotate. Therefore, ang ato is either summation of forces vertical or horizontal. For this case, let's take summation of forces vertical is equal to 0. But before using this, make sure nga na-define na iyang reverse effective force. So since ang direction sa acceleration is pataas, therefore paubos ang ato aning reverse effective force, which is again equal to the weight over g times the acceleration 2. Now, our acceleration 2 and the acceleration of the particle, which is tangent to this larger radius, are the same. And then naman tayo relation, no? Because this is the direction of the angular acceleration. We have a relation that A2 is equal to the bigger radius times the alpha. The bigger radius is 3 feet, so that is 3 alpha. We're going to use that, or we're going to use this later. So again, going back to the summation of forces vertical equals to 0 nga equation. So we take positive if the force acts upward, because this is the direction of our motion or the direction of our acceleration. So summing up, ang mga upward forces, we have T2. Then ang downward forces, we have the weight, 161, minus the reverse effective force, that is equal to 0. So we have T2 minus 161 minus the weight 161 over 32.2, alpha 2 equal 0. But we have a relation for alpha 2. I mean A2 day. A2 is 3 alpha. Therefore, we have T2 minus 161 times 3 alpha all over 32.2, that is equal to 0. Now let's rearrange this. So we have negative 161 times 3 all over 32.2. Tapos we have alpha, then plus T2 equals, pwede natin siya ibutang sa right side, ang constant equals 161. So this is our third equation. So sa atong tulo ka mga equations, naatay tulo ka unknowns, that is alpha, T1, and T2. So we can solve it simultaneously. So there is sa next nga slide, no? Solve the three equations simultaneously. using Calcutech, no? Mag-calcutech ta niyan eh. So, first equation, balik ta. Our first equation is this one, 322 over 32.2 alpha plus T1 equals 322. Okay, so we have 322 all over 32.2. This is alpha plus T1, then plus 0 T2 lang, makumplito na to, is equals to 322. Okay? Second equation. Okay, nalabas. Second equation, we have this. So, 10,045 pi alpha minus T1 plus 3T2. So, we have negative 10,045 pi alpha. I forget the T1. I think that's minus T1 plus 3T2. Okay. Minus T1 plus 3T2, that is equal to 0. And then for the third equation, kani siya, negative 1613 over 32.2 alpha plus T2 equals 161. So, negative 161 times 3 over 32.2 alpha plus T2. So, we have plus 0 T1, wa siya T1, plus T2 is equal to 161. Sakto ba? Okay, so sakto. So, we have three equations, three unknowns, then we can solve for T2 here. So, using our calculator for three unknowns, so mode, tapos equation 5, and then choose number 2 for three equations, three unknowns. So, input 322 divided by 32.2. T1 is 1, 0 si T2, tapos 322. Second equation, so negative 10,045, nakuha 10,045, shift pi equals, tapos negative 1, positive 3, 0. The last, negative 161 times 3 divided by 32.2. Then we have 0 and T1, 1 and T2, tapos we have 161. So the first is our acceleration, no? Alpha, which is very small, 5.11 times 10 to the power of negative 3. So alpha is equals to 0.00511. This is radian per second square. And then the next nga tumukuha is dt1. So equal na pagbalik. So we have equals. So 3 to 1.95. 3 to 1.95. This is pounds. And then our T2 is 161.08. So 161.08 pounds. For the first requirement, mo ni siya ang iyahang answer. Okay, so let's proceed to the second requirement, which is the bearing reaction, which is RO. So balik ta ani nga figure. Now, our compound pulley is only rotating along its center of axis or center of rotation. Meaning, nag-rotate lang, wala siya movement or wala siya translation, only rotation. Wa man siya ni move upwards or sidewards. Therefore, we can perform static equilibrium along the vertical. Okay, so solving for R not or the bearing reaction. We take summation of forces of the compound pulley along the vertical, that is equal to 0. So we take positive if upwards. Yeah. Now this is for static equilibrium condition. No, equilibrium condition. this is not came from the dynamic equilibrium nga assumption because our compound pulley does not accelerate upwards or downwards or leftwards or rightwards. Okay? So by nature nag-rotate lang siya, wala siya ni translate. So we can use the static equilibrium condition. So with this, we need to define those forces nga nag-interact sa compound pulley. So we have the upward force, only one, that is the bearing force, minus nasa weight sa pulley, minus T2, minus T1, that is equal to 0. Therefore, the bearing reaction is equal to the sum of the weight plus T2 plus T1. We already know the values of T2 and T1, but we don't know the weight of the compound pulley. Since given ang density, therefore, we can use the general formula. Density is the weight over G times the volume, the total volume. Therefore, our weight is equal to rho G times the volume. Okay? So, ingon ana ra. But, since nakapound naman siya, so just ignore the acceleration due to gravity. Okay? So, in case lang if our weight or ang ato ang mass is in slugs. Okay? Inyo po na makitaan kay manubra naman kung mag-multiply pa mo G, manubra ayahang units. Solving for the weight, I mean for the volume pala. Volume is actually duha ni siya ka cylinder, no? We have the inner cylinder if we draw its cross sectional, no? So again, this is 0.5 feet and also this 1.5 feet. So duha ka cylinder nga nagkalahi-lahi ilahang mga radius. So kani is 3 foot. I mean 3 feet. This is 1 foot. Okay. So volume ani we have pi small r squared times 0.5 plus pi the huge r squared times 0.5. Na I'm a factor, so we have pi times 0.5 and then we have small r plus the large r. Therefore, our bearing reaction, the weight is again density times pi times 0.5 tapos r squared plus r squared plus T2 plus T1. So, mag-substitute ang values. We have 490. We have pi. We have 0.5. The inner radius is 1 foot. The outer radius is 3 feet. Then tension 2, nakuha kaganiha. That is 161.08. So 161.08 plus tension 1 is 3 to 1.95. So 3 to 1.95 pounds. So therefore our bearing reaction, let's just put it here. So we have, let's go back to the computation mode, 490 times shift pi times the height 0.5 times 1 square is still 1 plus 3 square plus 161.08 plus 321.95. So we have 8179.93. So 8179.93. This is in pounds. Okay, so this is our bearing reaction at the center of rotation of this pulley. Now, going back to our result, no, we have T1 and T2. Now, if ato kitaan tong mga weights, no, kaganiha, again, T2 is 161.08, T1 is 3 to 1.95. Okay, let's go back to the original figure. So this is the original figure. Now, ang nakuha atong attentions diri is, I think that is 161 point something, no? 5. And then this one is around 321 point something. Kung inyo ma-notice, may gamay ang tensions diri due to the acceleration pa downward. So, with the acceleration pa downward, mura sa man, wa na siya ni effort ang ato ang right side nga, I mean ato ang right nga rope, no? Kaning rope nga nasa right. Whereas, on the other hand, ang rope nato nga nasa left, ang tension niya kay nanubra sa iya weight, which is 161, nilapas na gamay, no? So, gamay na ang sobra. It's because itabang siya bira aning 161 para mo-move siya upward. So, mo na ang interpretation. Now, gamay ra og ligas, it's because gamay ra sad ang difference pud ani ning 161 pounds and 322 pounds. And usapod sa mga factor ang saman kabug-aton pod sa ato ang pulley, which is its mass moment of inertia. It also plays an important role in this analysis. So, gagmay rag ligas sa mga tensions sa kada blocks, it's because ang ato pod nakuha ang alpha is very small, no? Ang rotational acceleration sa ato ang compound pulley is just 0.00511 rad per second square. Okay, so this is how you're going to interpret your result from the given problem. Okay, so wala ba may mga concerns, pangutana with regards to our first problem? Wala pangutana, class? Hello, naka-follow pa mo? Hello, anay pangutana? Wala na. Okay, mura mag natog na siguro ning uban. Okay, so proceed ta. Proceed ta sa second problem. So problem number 2, find the tension daw in the cord attached to block A in figure below. This is the figure. Very complicated, but ato na siya syempre analyze, mag-create og FBD so that ma-simplify nato. So this is a compound pulley gihapon with two blocks but of different arrangement. So luckily, given the tag moment of inertia which is equal to 40 foot-pound per second square. So neglect daw the weight of the floating pulley, supporting weight B. So we have here a floating pulley na sa block B. And the answer, this is from the book of Singer, 192 pounds. Ato na siya kuha na siya nga answer. Okay? So mo na siya ato ang figure. We have our first object, block B, still dili kayo significant sa iyahang dimensions, and block B is very small compared to its direction of travel or its path. Therefore, we consider this as a particle. For our second object nga atong na-identify, we have this compound pulley. No, na siya yung mga different radii and diameters or diameters. So, kuan siya, significant ang iyahang mga dimensions, very important in our calculation. Therefore, we consider this as a rigid body rather than a particle. For our third object, block A, we consider this as a particle because its dimensions are not too significant, and then its size is smaller compared to its path of travel. After defining the objects in our system, then let's proceed to the creation of its FBD. This is very important. So I enlarge this system, tapos gipa-blur po diya color so that ma-emphasize sa mga forces nga nag-interact. Mag-start ta sa sa block number 1. Obviously, na siya weight pa downward, 400 pounds. And then may mga tensions sa kaning rope. So for block B na atay duha ka ropes na involved, kaning straight lang and then kaning ni pass through aning floating nga pulley, no, ni pass through siya. So ato i-assume nga ang tensions aning floating pulley kaning sa babaw nga rope T1. So duha ka T1 because duha man ka rope dira, and then 2 T1 na siya dira. So why 2 T1? Because if we take summation of forces along this floating pulley, we found out, no, I also explained this one sa ato ang consultation sa quiz number 1 for dynamics. So if natay T1 diri natay T1, therefore this is the T below is twice of the forces upward, no, to make the floating pulley in equilibrium state. In the same manner, we can also say that ang acceleration pud aning a part, no, kaning upper part, the acceleration sa upper part is equal to twice the acceleration of our block B, no, AB, because ang displacement po diri no, sa kaning rope, ang displacement niya if it moves 2 units, so ang movement niya sa 2 units is equal to 1 unit ra sa kaning block B. That is why mo correspond po na siya sa ilang mga accelerations. Bali hinay nimo accelerate si B, kanang rope nga naka-attach ni B, hinay siya og acceleration compared sa rope nga ni encircle aning ato ang floating pulley. Okay, so remember that one. Now nabot tay reaction sa kaning gi-attach sa kaning upper nga rope R1. Then focus ta sa block A. So naatay component forces for its weight, which is WT. This is along the inclined plane, and we have WN, which is the normal component of the weight. Then we also have the normal force kay ni rest man siya sa surface, automatic na ay normal force nag-exert. And then of course connected siya sa rope, so we have T2 here. Okay. Now, ang ato ang inclined plane na siya frictional force because given ang F, ang coefficient of friction, which is equal to 0.2. But in this state, we cannot determine yet kung asa ang direction sa frictional force. It could be up the inclined plane or down the inclined plane. So we cannot distinguish yet, we cannot tell yet because we lack the information for the direction of motion. Wata kay baw, asa ka na siya mo travel ato ang block A or block B, either pa upward ba or pa downward. So if ato i-analyze ang ilahang mga weights, block B is heavier than block A, therefore si block B mo move downward. So it's have its acceleration A sub 1. Okay? And then our compound pulley, if pa downward ni si block B, so therefore pa clockwise po ang rotation sa compound pulley. In the same manner, if pa clockwise ang rotation sa compound pulley, connected man ang ato ang block A via this rope, therefore birahon siya pa upward, no, up the inclined plane. This is A2. With the direction of motion, then makatel na ta nga ang frictional force is pa downward siya. So F, represented by this F. Now what else? Our compound pulley, of course, has its weight, WP, and then, of course, di mawa ang bearing reaction, the same thing as what we did in the first problem. So R not. Okay? So after this, by the next slide, we are going to dissect, no, these three objects, then we perform summation of forces. Let's start with the block B, no? The first object, which is a particle. So mo na siya ang mga forces nga nag-interact. So this is the direction of motion, which is downward, therefore its corresponding REF, no? REF is upward, which is equal to its weight over G times A1. Now, since ang kaning rope sa upper is connected ria, which is tangent to this circle with radius of 3 feet, since ang alpha is pa-clockwise alpha, so therefore the acceleration at this point is ato la labeled as acceleration upper is equal to the radius, the bigger radius times alpha, or that is equal to 3 alpha. Now, ang ato ramang na-define nga acceleration is the A1. So, we need to relate A1 with AU, no? With this pulley arrangement, meaning si upper rope kay mo travel siya twice than the lower rope. So therefore, the acceleration at the lower rope, which is A1, is just half of the acceleration of the upper rope. So we have 3 halves alpha. Okay? So with this, proceed to sa summation of forces because we already defined the REF. So we take summation of forces vertical, ma-zero na. So plus ta if pa downward siya because that is the direction of motion or the direction of the acceleration. So sa may downward forces, we have the weight, 400 pounds minus the tension, so 2T1, no? This one, 2T1. And then minus sa REF, that is equal to 0. So we have 400 minus 2T1 minus 400, the weight over G, which is 32.2, times the acceleration 1, that's equal to 0. But we already solved for acceleration 1, that is 3 halves alpha. So therefore, 400 minus 2T1 minus 400 over 32.2 times 3 halves alpha is equal to 0. Okay? So 3 halves times 400, that is 600. So rearranging this, no, para mahimo na siya og 600, negative 600 all over 32.2 alpha. So again, 400 times 3 halves is 600. Okay? So next, minus 2T1 and possibly ang another unknown ani is T2. So let's add plus 0 T2 na lang. Anyways, it will not affect the equation because 0 times T2 is 0. So maragwa ra. And then ato lang i-transpose ang 400 on the right side, so minus 400. And I think multiply pag negative para positive tanan. So 600 over 32.2 alpha. So this is, sorry, sakto. Ito lang i-erase bigyan nagkahuga na. So, di naman siya minus, plus na siya. So, plus 2T1, this is plus 0T2, pwedeng minus, anyway, di man na mag-matter kay 0 man. So, that is equal to 400. This is our first equation. So, kindly take note with this. Next, jump forward ta sa ato ang compound pulley. Okay? Our compound pulley mo na center of gravity, which is also the center of rotation. So, rotation ang iya motion, dili rectilinear translation. So, therefore, apply ito na katong centroidal rotation nga topic. So, we take summation moment along the center of gravity, which is equal to the centroidal moment of inertia or mass moment of inertia times alpha. The direction of our alpha is clockwise. So, therefore, we take positive kung ang mga external forces is pa-clockwise po ilahang direction. No? So, summation of moments. Ato i-define ang mga forces nga maka-cause og moment sa ato ang compound pulley. For the weight and the bearing reaction, dili ni sila maka-cause because they don't have moment arms, no? Because they are directed towards the axis of moment. So, zero ilahang moments. We only have T1 and T2. So, si T1 lang ang makapakos og clockwise nga rotation whereas T2 pa-counter siya. So, we have T1. Tapos, iya moment arm is the bigger radius. So, we have R minus T2. The smaller radius is R is equal to I bar alpha. From the problem, our I bar is given by 40 foot-pound second square. So 40 foot-pound second square. Okay? So, next, given mo ng R, ato lang ikuan, R is 3 feet. The small r is 2 feet. Okay. So, diri ato i-substitute. So, we have 3T1 minus 2T2 is equals to 4T alpha. Now, let's rearrange this. Ato pa transpose ang duha on the other side. So, we have 4T alpha. Next, si T1 followed by T2 and then the constant. So, 0. Wala may constant 3. So, therefore, this is our second equation. With the three unknown forces, with the three unknown variables, alpha, T1, and T2, so, need po taog tulo ka mga equations. So, one more na lang ato ang pangitaan. So, di na nato makita sa block A or the third object. For the third object, wala man ni rotation, only rectilinear translation along the inclined plane. So we take summation of forces, una, normal sa inclined plane that is equal to 0. No? That is positive kung pa-upward. Okay? And then since na may direction sa alpha, A2, no? So pa-upwards man, therefore the reverse effective force is pa-downward. This is REF, which is again equals to the weight over G, no? Times the acceleration. This is A2. Now, we need to find a relation of A2 in terms of alpha, no? Rotate mo niya ang compound pulley with alpha. So the acceleration of block A is also similar to the acceleration at this point along this circle. So ang acceleration po ani niya is just the product of the radius, no? So we have A2 equal to the small radius times alpha, or that is equal to the radius is 2 feet times alpha. So nalatay relation sa A2. Now, balik ta sa summation of forces normal. So, mano siya ang normal axis. So, ang summation of forces na yana, we only have 2, which is ang upward force is normal. That is equal to the normal component of the weight. Or that is equal to the weight cosine of theta. So, this is our theta. No? With this representation, this is 4, 3, 5, an Egyptian triangle. So, cosine theta is automatic 4/5 by this triangle, and then our sine of theta, that is equal to 3/5. So, next, we have this normal force. So, we take summation forces kanang tangential or tangent sa or along the inclined plane, that is equal to 0. Kaya na-define naman ang REF. So, we take positive kung up the inclined plane ang direction sa force. So, unsa man ang mga upward forces? We have T2, and then, I think wala na. So, minus the tangential component of the weight, minus the frictional force, minus the REF, and that will equal to 0. So, T2 minus, this is weight sine of theta. The frictional force is again the coefficient of friction, actually represented by mu, times the normal force N, minus this one is weight G times alpha 2, that is equal to 0. So we have T2 minus the weight sine theta minus mu, this is weight cosine of theta, minus weight over G, this is 2 alpha, no? Ito i-substitute via 2 alpha. So this is 2 alpha because of this, no? Alpha 2 equals 2 alpha. Next, rearrange, no? To rearrange, una si alpha, so we have negative. The weight of this is The weight is, I forget the weight. I forget to write the weight. Okay, 200 pounds. Okay. So we have negative 200 times 2. So automatic, this is 400 over 32.2. This is alpha. We don't have theta 1. So, we don't have T1. So plus 0 T1. And then we have plus T2. And then equal na sa kaning W. After I factor out, we have sine theta plus cosine theta mu. Okay. So this is our third equation, no? So let's combine these three equations sa next slide. So combining, no, solve simultaneously. The three equations. So we have our first equation, going back sa previous slides. First equation, 632.2 plus 2t1 equals 400. So 600 all over 32.2 alpha plus 2t1 plus 0t2 equals 400. This is our first equation. Second equation, we have 40 alpha minus 3t1 plus 2t2. 40 alpha minus 3t1 plus 2t2 is equal to 0. So second equation. Let's erase this. So the third equation, the previous, so this is negative 400 over 32.2 alpha. Okay. Then we have 0t1, so plus 0t1 plus t2 equals to the weight. So the weight is 200. So we have 200 times sine of theta is 3/5. So we have 3/5 plus the coefficient of friction times cosine theta, which is 4/5. So plus 4/5 times the coefficient of friction is 0.2. No, given man kani siya. Okay, so we have three equations, three unknowns. Then we can use our cycle. So go to number 5 equation, choose number 2 for three equations, three unknowns. So input 600 divided by 32.2. Then we have 2t1, 0 si t2, tapos 400 ang constant. The next, we have 40 alpha, then negative 3t1, we have 2t2, tapos 0. And finally, we have negative. So we have here, this is negative 400 divided by 32.2. Then 0 si t1, 1 si t2, we have 200 times 3 divided by 5 plus 4 divided by 5 times 0.2, another close parenthesis, another close parenthesis. So 152. So we have our alpha 3.19. So alpha 3.19, this is rad per second square. And then our y 170.28. So T1 is 170.28 pounds. Then our T2, we have 191.63. So 191.63 or approximately 192 pounds. mao na siya ang ato ang pangita, which is same sa kaning nasa book. Okay, I show this to you since wala naman ni siya gi-include to sa solution sa katong gi-forward sa inyo nga solution manual. So ako siya gi-solve just for you, and then try to study this. Okay? So ano ba yung question so far for our second problem? Okay, wala na. So I'll just end the recording now.